Alright, this is the last part of lesson 1.10, and now we're just going to work with some more difficult problems. We have variables on both sides of the equation. So let's do this one. 2x plus 9 is equal to 5x minus 12. Now I really have to worry about getting all my variable terms on one side and all my constant terms on the other. And it doesn't matter which way you go. Like, you can subtract 5x and put it on this side, or you can subtract 2x and put it on that side. Just like, you just need to be aware that if you were to subtract 5x over to here, you end up with a negative variable term, so that when you're dividing in the end, you make sure that you include your negative sign. And so it doesn't matter whichever way you want to do it. I personally am going to subtract 2x from both sides, so I move my 2x over here. And make sure in your notes that you guys are showing every step like I am, so you can see the process that you are taking, and I want you to do one step at a time. I don't want to do my variable terms and my constant terms at the same time. Not right now, in the future, sure, but not now. So I'm subtracting these. I'm not dividing them, because I'm just moving them. I'm not dividing by 2, I'm just moving them over. So I'm left with a 9 on this side, and that's equal to 3x minus 12. Remember my constants to this side, I'm going to add 12. These will cross out. 21 is equal to 3x. I'm going to divide by 3 so I can isolate my variable. 21 divided by 3, I will have 7 is equal to x. And that is good. Okay, and now we're going to have this one, 2 times x minus 3 is equal to negative 8 plus 4x. Oh my goodness, we have some parentheses, so I need to distribute in order to get rid of my parentheses. So when I do that, I'm going to distribute my 2 into everything inside the parentheses. So I have 2 times x, 2x. 2 times negative 3 will give me a negative 6 is equal to negative 8 plus 4x. And now I want to bring all my variable terms to one side. Again, I'm going to subtract 2x. You could subtract 4x if you want to and bring it over here. Okay, funny one. I'm left with negative 6 is equal to negative 8 plus 2x. And now I'm going to add 8 and bring that over here because I have a negative 8. These cross out. Negative 6 plus 8, I have a positive 2, and that's going to be equal to 2x. So one more step to get x by itself. I'm going to divide both sides by 2. These cross out. 2 divided by 2 is 1. So x is going to be equal to 1. And you can put a box around it, and you're done. Awesome. Purchasing a car. So you are interested in purchasing a new car, and you have narrowed the choice to a Honda Accord LX and a Passat GLS, and being concerned about the value of the car depreciating over time, you search the internet and obtain the following information. You obtain this. So our Accord LX is the retail price of that is $20,925. And the Passat GLS, the retail value of that car is $24,995. And the depreciation, the annual depreciation of both of them, for the Accord, our depreciation is, so it goes down. Why can't I write today? What is wrong with me? It goes down $1,730 per year. And the depreciation of the Passat is $2,420. All right, we got our information. We know that. And so what I want to do is I want to write an equation modeling both of these. But my overall question is going to be, I want to determine when the value of the Accord will equal the value of the Passat, because the Passat depreciates faster, so after so many years, their value will be equal. And so I'm going to want to put my Accord LX equation on the left-hand side, I'm gonna put out the SOT equation on the right-hand side, and then I'm gonna solve to figure out the amount of years. So my chord equation, it's gonna be $20,925, and then I'm gonna subtract $1,730 per year. So we need a variable for year, and I'm gonna have y equal years. My chord, I'm gonna have $20,925, and that's gonna be subtracted by $1,730 per year, so times x. And that, I want to know when it's going to equal the Passat's value, which is $24,995, and it depreciates by $2,420 per year, so times x. So now do you see how we can just solve for x on this one? I want to get all my constants on one side, all my variables on the other. Life is good. So I'm going to add my 1730 over here. These can cross out, and I will have 20,925 is equal to 24,995, and then negative 2,420 minus or plus 1730, good God, is equal to a negative 690x. And now I want to bring my constant term over here, so I'm going to subtract 24,995. Okay, so when I do that, I'm going to get a negative 4,070 over here. Okay, let me write that up here. So over here I got negative 4,070, and that is equal to our negative 690x. Now, last step, I'm going to divide by negative 690. And my x is going to equal, to be positive, because we have two negatives, so it's going to make a positive. And this will equal about roughly 5.90, I'm going to round. So after almost 6 years, the value of these two cars will be equal. And now I think that you guys have 3 of these also to do on your own, so good luck with that.